In this video, I'm going to demonstrate how Kioptrix Level 1 can be exploited in a controlled lab environment and explain what is happening at each step. First, I set up two virtual machines. One is Kali Linux, which acts as the attacker machine, and the other is Kioptrix Level 1, which is the target. Both machines are placed on the same host-only network so they can communicate with each other. Next, I start by scanning the target machine using a network scan to see what services are running. The scan shows that the target has Samba services running on ports 139 and 445, along with the web server. Samba is important here because older versions of it are known to have security issues. After identifying the services, I look up the Samba version and find that it is an older version, which is vulnerable to a known buffer overflow exploit. This means that the service can be attacked in a way that allows an attacker to overwrite memory and potentially run commands on the system. To take advantage of this, I use Metasploit and select the exploit for Samba called trans2open. This exploit is designed to target the vulnerability in the specific version of Samba. Then I configure the exploit by setting the target IP address, which is the Kioptrix machine, and my own IP address, which is my Kali machine. I also set the payload to a reverse shell so that the target machine will connect back to me once the exploit works. After everything is set, I run the exploit. At this point, Metasploit begins trying different return addresses while attempting to trigger the vulnerability. It may look like it is hanging, but it is actually working in the background. After a short time, the exploit is successful and a command shell session opens. Now, this means I now have remote access to the target machine. However, I need to manually connect to the session using Metasploit session commands in order to interact with it. Once I do that, I can start running commands on the target system. To confirm access, I run the whammy command. The output shows that I am root, which means I have full administrative privileges on the machine. This is important because it shows that the vulnerability allowed me to gain complete control of the system without needing a username or password. In conclusion, this lab demonstrates how an outdated service like Samba can be exploited using a buffer overflow attack. And it also shows the importance of keeping systems updated and removing vulnerable services. Without proper security updates, an attacker can gain full root access to a system very easily. This taxonomy of attacks groups common cybersecurity threats by how they work and what part of a system or user they target, helping to explain the different ways systems can be compromised. We start with social engineering attacks. These target people instead of systems by tricking users into giving up information or clicking malicious links like phishing emails. Next are viruses. A virus is malicious code that spreads by attaching itself to files or programs and can damage or disrupt systems when activated. Then are Trojans. A Trojan is malware disguised as something safe, tricking users into installing it so attackers can gain access or control. Backdoors come next. These are hidden ways to access a system without normal login steps, often used for secret re-entry later. Rootkits are designed to hide on the system. They conceal files, processes, and activities so attackers can stay undetected. Privilege escalation happens when an attacker gains higher access rights than they should have, like moving from a normal user to admin or root. Return-oriented programming is an advanced technique where attackers reuse existing code in a system to bypass security protections. Finally, buffer overflow is when a program stores too much data in memory, which can overwrite parts of the system and allow attackers to run malicious code.